So I recently stumbled upon this article called Life-Altering Postgres Patterns. And honestly, as a person who is still learning about databases, and it's been my weakness for a long time, I found this article very interesting and very useful because it gives us advanced topics, advanced concepts in a very simple fashion. And I'm going to try to make a TLDR out of it and share it with you guys. So even if the article is called Postgres Patterns, it usually applies to most of the relational databases, and I'm going to point out the differences as well. With that said, thank you to Ethan for writing this beautiful article, and let's get started with the very first bullet point, usage of unique identifiers for primary keys. So unique UUIDs have downsides, okay? They're random, which is good, but they also don't sort well because it's literally a patch of a string that you can use as an ID. Obviously, it's hard to sort a long patch of a string compared to an auto-incremented integer, right? Also, they take more space than normal IDs. But keep in mind that space is usually our cheapest resource. Now, we found that actually unique identifiers are much better than anything else. Why? First of all, you don't need to coordinate with other databases to produce one, safe to share externally. I don't really buy this point, but my point would be actually that it's much easier to scale and do everything about scaling because you are not going to have collisions with other replicas of your database because every entry in your database is going to be unique. So in case if you need to merge some data or something like that, your entries are always unique, have a unique ID, so it's much easier. Now let's talk about unique identifiers themselves. First of all, normally you would run into V4s because unique identifiers have versions as well. V4 is, I would say, the common standard at the moment, and it's going to look something like this. But there's also V5 and even V8, I believe. V7, not V5. V7 is not as commonly used, although it would actually avoid the problem with sorting because they have a timestamp before. So this part is going to be a timestamp. So actually database can sort these entries much easily. The thing is, not all the databases currently support it. For example, Postgres only support it, but you need to enable special extension. Similar thing applies to other databases as well. All right, so this is the first point. Now let's go to the second one. Give everything created at and updated at columns or values rather. Why? Well, this is very simple. It's much easier to later analyze your data and sort through your data based on timestamps. For example, when the row has been entered the database, you can assign a value for created at and updated at. And most of the ORMs, or let's say libraries that help you interact from your code with the database, are actually doing this by default. So make sure that you don't really turn it off. Although the downside is that now you have extra 2 columns. So I think it always makes sense to consider it on a use case base of a use case, meaning if you don't really think your table needs a created at and updated at columns, you can also avoid it. The third point is about restricting a row being deleted by adding delete restrict. So what is it actually? Let's look at this code. So here we're creating a table called person, and created at and updated at are as normal, but in the second table called pet, we have a owner ID and it says references person, so the person's ID, and on update delete, or on update restrict, on delete restrict. What does it mean? So it means that the parent table that references another table has some relationship here. So the owner ID references the person's ID. The thing is, when you use something like this on update restrict or on delete restrict, you're not able to delete the child row without or you're not able to delete the parent row without deleting the child first. This helps with the fact that you're not going to end up with some inconsistency. Well, there's also another keyword called cascade, which means if you remove the parent, all the children are also going to be deleted automatically. Now, in this article, we're arguing for actually using delete restrict, which is going to throw an error and not allow you to delete the entry rather than using a cascade. Again, depends on your use case, but using delete restrict is more safer because In this article, we're saying that better to error than do something like cascade, because storage is cheap, as we said, and recovering data is a nightmare. Also, let's not forget about schemas. Yes, schemas exist, and in some databases, such as Postgres, schemas are supported by default, so every time or every table in Postgres will automatically go to a public schema. This is fine, but you're missing out on the advantage if you don't declare a new schema and add your tables under it. For example, let's take a look at this example. Here we create a schema called vet, and under the vet schema, we can create a table called person. So it's basically kind of a namespace for databases. Okay, now you may ask, why would you need this? Well, for better modularizing and structuring your database. It's clearly visible that this person table now belongs to a different namespace where we talk about vets specifically. This is cool, but on the other side, some databases actually don't have schemas. For example, MySQL. In MySQL, you would have to create a separate database for this. You don't have an option to create schemas. So if you're using something like Postgres or MS Server, you can safely, I believe it supports that you can safely use schemas. And the cool thing about schemas is that you can join them, fine. You can also assign specific permissions per schema. So let's say if you have a specific schema related to some confidential admin information, a normal user or a normal database user will not be able to access the schema unless they have the permissions for this. So this is a very cool thing, but obviously don't overdo with schemas. Enum table, another interesting concept. We all know enums in the field of programming, but there's also enum tables in databases as well. Well, let me show you an example. Actually, I created it with ChatGPT, which looks actually simpler. So instead of doing this, which is create table orders with an ID, which is a primary key, which is integer, and status, which is the enum value, so to say, you can actually create a table called order statuses and then have a name, which is again varchar. And this is going to be used as an enum because in the orders table, we have a foreign key which uses the status ID and references order statuses ID. So basically, this is an enum representation in a database that you can use. And the cool thing is that most of the databases have a specific enum system variable that you can use. So to create an enum, it will be very simple. You could just create a table called shirts, and then you give it a name, for example. And then for the size, you can say it's going to be an enum, meaning only the following values are going to be accepted as a size. Now, the next point is also quite smart because it says mechanically name join tables. It's a very simple idea, but what we're trying to say in this point is basically when you create full joins, for example, you're joining literally one table with another, you don't need to come up with some complicated name. And sure, naming is very important in programming and overall. If you're joining tables called person and pet, you can simply call it person pet, as simple as that. Now let's go to the next point. We're going to say that it's always good to do soft deletes. Now, this can be controversial. It was also for me when I first started learning about databases and how most of the businesses work. What I'm trying to say is that when you ask a company to delete your data, they're actually not going to do that. Yeah, most of the companies are not going to do that. What they're going to do instead is soft delete. What does it mean? They will try to anonymize your name in their database, but they're still gonna keep all the data or all the logs that you produced. For example, let's say you're an Amazon user. If you made some orders on Amazon and you bought things and then you try to delete your account, they're gonna delete your timestamps because timestamps are actually private data that's under the GDPR law, so companies are not able to store the timestamps. They're also going to delete your name most likely and surname, but they're not going to delete all the orders that you've made because it's very important for the statistics and blah, blah, blah. So what we're trying to say here is that every time you're deleting something, make sure that you delete the entry softly. Yeah. What are we trying to say here? You can say that revoke that. This is a column that we're going to use for deletion. So what we're going to say, let's say an ID can be obfuscated, a username can be obfuscated, but instead of deleting the entry at all, we're simply going to use this column called revoked at and add a timestamp to it. Now, if we always have a column called revoked at, but the user still exists, let's say the user is not deleted, it's an active user, then this revoked at is going to be nullable. Okay, it's gonna just have a null. If it has a timestamp, it means it actually got revoked. If it doesn't, then it's an active user, which means every time you select the data from the database, you're going to have to filter by not nulls at the revoked at column. And this is going to add an overhead. What you can do to mitigate that, you can index the revoked at column to make it a bit faster, and also create views so that you don't have to bother by filtering that every time. Now let's talk about views. And we're saying use views sparingly. What does it mean? Well, views are making our life easier. Let's say you have this table, and every time you're trying to do this query here, or rather this query here, select too many things from the table and from and where clauses, well, you can actually pack this into one view. For example, where we're creating the view, actually this is where we're creating the view. So every time you want to get this data, you can simply call this view called active prescriptions. Okay, simple, but always be aware not to create too many cascading views, meaning views can rely on other views. And views are inherently obfuscating or hiding the logic under the hood, meaning if the query is non-performant because it's been constructed in a bad way and you want to debug it at a later point, you will have to go through really multiple views to actually found the core problem. And this can be not very efficient in the terms of debugging. That's why use views sparingly, meaning views are great to simplify some things. Also, you can assign different permissions per view for a user, not to be able to access certain views. So just keep in mind that views can come at a specific cost, although they are simplifying our work at the same time. Last but not least, JSON queries. Yes, modern versions of Postgres, MySQL, and actually most of the databases nowadays will support JSON queries. What is this? We basically are saying that within a column, you can use a JSON structure. Now, why would you use that if you have document-based databases such as MongoDB? Now, the thing is, JSON queries are really good for not normalized data. Okay, let's say a user table always has some kind of properties that are not the same for every user. In this case, actually using a JSON would be beneficial. What does it mean? So you can literally take this and put it into one column, but let's say the next user actually doesn't have contact info, which means you don't have to create a separate table in this case, but you can usually just use JSONs. They're much flexible. Now, some precautions that we also need to keep in mind. You can see that this is a nested JSON, or let's say it has two levels because it's an array, and then inside an array we also have another array. This one looks fine, but I would say don't try to nest it much, because then when you're trying to retrieve this JSON, you will have to do some funky stuff. Okay, you will have to use a specific index, which looks a bit funky. So don't try to nest this JSON queries or JSON data too much. I hope you guys liked this video. If you did, smash like and let me know down in the comments if you found something interesting, if you learned something new. I'm gonna see you guys in the next one, and all the best to you.